Now let's see this question. How many two-state DFAs can be constructed with a designated initial state that accept the universal language over alphabet A comma B? Now if you observe it, they are talking about two-state DFAs. Therefore the number of states that you are supposed to have in DFA is 2, and designated initial state is given, which means one of the state is designated as the initial state, right? Now they are saying that accepts the universal language and alphabet is just 2. Now what is universal language is, it should definitely contain epsilon, and it should definitely contain a, b, and it should contain everything, every possible string with this a comma b, right? So all the strings of length 1, all the strings of length 2, right, all the strings of length 3, so on. So it is supposed to accept everything. That is universal language. Now how to solve this one is, as you know, we are supposed to accept epsilon. So let's try to draw the basic skeleton here. Two states are given, x, let us assume that they are x and y, and they are saying that one state is designated as initial state. Therefore coming to initial state, if you had chosen that x is going to be the initial state, you are not supposed to later change it to y. So it has to be only one state and it has to be fixed. So let's fix the initial state as x. Now if a language has to accept epsilon using a DFA, I mean if epsilon has to be present in the language, then in the DFA for that language always initial state should be final state. That is why if you assume that x is going to be the initial state, then it is supposed to be final state as well, right? And only 2 are given. Now coming to y, it can be a final state or it need not be a final state, right? So what you can do is, now let's assume that x is y is also a final state. It can be a final state or it need not be a final state, right? Which means the other type of structure you are going to get is, this is final state and is not the final state. So there are the two types of structures we get. Now once I have this, once I have both the states as the final states, irrespective of the transitions, everything will get accepted. Whichever way you put the transitions, everything will get accepted, right? Therefore either if x goes to x on a or x goes to whatever happens, right, irrespective of what is going to happen, always, okay, so always everything will be accepted, right? So now if you observe this, what I mean to say is, we are writing like this: x is a final state and y is a final state. Now definitely, since initial state is equal to final state, epsilon will be accepted. Now whichever way you put the transitions a and b here, everything will get accepted. Whichever you go, it will be accepted, right? So it is going to accept the universal language. Now how many such DFAs are possible with this structure, which means x is the initial state and final state, y is the final state. So how many different structures are possible is, or different DFAs are possible is 16. 2 into 2 into 2 into 2, 16. Got it? Now coming to the other one, let's see how many are possible here. Now here y is not the final state, therefore everything has to be accepted in x only, right? So x is the final state, right? Now epsilon will be there. If I have to have x, let's say this is y, okay? If I have to accept a and b, definitely a and b have to be here itself, right? Which means the transition of x on a has to be here and of b should be here, right? I cannot move from x to y on seeing a. If I do so, then I'll not be able to have this a in our language. But since it is a universal language and everything is supposed to be there in the language, I cannot do that, right? Therefore on x, on small a and small b, both of them have to stay in x itself. So I don't have any choice here. Now coming to y, it doesn't matter, right? So either you stay there or you move, it doesn't matter. Therefore you can have capital Y on small a can go to either x or y. Similarly capital Y on small b can go to either x or y. Got it? So we have 2 into 2. which means 4. So 4 DFAs are possible this way and 16 DFAs are possible this way. Therefore, the total number of DFAs possible are 16 plus 4, which is 20. Right?